Let's try an example solution stoichiometry. So 25 ml 0.1 molar iron nitrate is added to 25 ml 0.1 molar sodium hydroxide. So already some alarm bells should be going off. Ding, 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 ding. I've got too much information, so this is a limiting reagent question. So we haven't even got a balanced chemical equation here. So that's the first thing I'm going to look at. I'm going to get my data sheet out. I'm going to check out the solubility tables to find out which of these will precipitate. Now, from my solubility tables, I can see that the iron 3 ions will react with the hydroxide ions to give iron 3 hydroxide precipitate. So now we've got a balanced chemical equation. So like any stoichiometry, the first thing we're going to have to do is we're going to find the mole. So I'm going to go the number of moles of iron nitrate is equal to CV. So the concentration was 0.1 times 0.025. Remember, it has to be in litres, and it comes out to 2.5 by 10 to the negative 3 moles. Now I can find the number of moles of iron 3 ions, which will be the same. And the number of moles of the nitrate ions will be, if you look at the equation, 3 times as many, which is 7.5 by 10 to the negative 3 moles. I'm also going to find the number of moles of sodium hydroxide, which is equal to CV. Our concentration is 0.1 times the volume of 0.025, and this comes out to 2.5 by 10 to the negative 3 moles. And if you look at this, this is all 1 to 1, so the number of moles of sodium ions will be the same. And the number of moles of hydroxide ions will be the same. So now I'm ready to go. First thing I'm going to do is I'm going to try and find my limiting reagent. So I always like to use the pick and choose method, and I'm going to try iron 3 as a possible limiting reagent. So that means I would need to find the number of moles of hydroxides using unknown over known times the number of moles of iron 3, which will be equal to 3 over 1 times 2.5 by 10 to the negative 3, and this comes out to 7.5 by 10 to the negative 3 moles. Now I must ask the question, do I have this much hydroxides? So going to check out my actual amount of hydroxides, I see that I have 2.5 by 10 to the negative 3 moles, and I actually need 7.5. So I don't have enough. This means that the limiting reagent is hydroxide ions. So now let's start tackling part A, the mass of the precipitate. Now that we've decided our limiting reagent is hydroxide ions, we can find our unknown in this case, which is the iron 3 hydroxide. So the number of moles of iron 3 hydroxide is equal to unknown over known times the number of moles of hydroxides, which will be 1 divided by 3 times 2.5 by 10 to the negative 3, and this comes out to be 8.33 by 10 to the negative 4 moles. I can now find the mass of the iron 3 hydroxide, is equal to number of moles times formula mass, which is 8.33 by 10 to the negative 4, times our formula mass, which I'm going to get off the periodic table, which is 106.874, and this comes out to be a mass of 0.0891 grams to 3 significant figures. Now we're ready to start part B. Now part B asks us to find the concentration of all the remaining ions in solution. Well, hydroxides, as they're the limiting reagent, have a concentration of 0 moles per litre. So our next point is to find the concentration of the other ions. Now I'm going to leave ion 3 to last because that's the hardest. I'm going to do the spectators first. So the concentration then of the nitrate ions is equal to N on V. So I need my new volume, so the total volume equals 50 ml. All I do is add the two volumes together. So the number of moles of the nitrates hasn't changed, 7.5 by 10 to the negative 3, divided by 50 ml, and it comes out to 0.150 molar to 3 significant figures. I can also do the concentration of the sodium ions because that's also a spectator, nice and straightforward, number of moles divided by volume. The moles haven't changed, divided by 0.05, and it comes out to 0.0500 moles per litre to 3 significant figures. Now the tricky one is the ion 3, because some of that was consumed in the reaction. So we have to find out how much was used in order to find out how much is in excess. So the number of moles of ion 3 used will equal unknown over known times the number of moles of hydroxides, which equals unknown is 1, known is 3, times 2.5 by 10 to the negative 3, and this comes out to be 8.33 by 10 to the negative 4 moles. Next bit, number of moles of ion 3 ions in excess equals number of moles of ion 3 ions from the start minus the number of moles of ion 3 ions used, which is equal to 2.5 by 10 to the negative 3 minus 8.33 by 10 to the negative 4 comes out to 1.67 by 10 to the negative 3 moles. Last step, the concentration then of the ion 3 is equal to number of moles over volume, which is 1.67 by 10 to the negative 3 divided by 0.05, and this comes out to be 0.0333 moles per litre to 3 significant figures. And voila, it's all done.